This video is of our 6.4 notes, and it's for anyone who is absent or anyone who wants a refresher. So the 6.4 notes are about the perimeter of similar polygons. We're going to start with a quick review of what we've already learned. We did a dilation activity in 6.2, and we wanted to remember, what did we learn about the perimeter of the shapes we dilated? How did the perimeters change once they've been dilated? Well, let's think about what happened to the original side lengths. The original side lengths, when dilated, were multiplied by the scale factor to get the new side length. The perimeter did something similar. So the original perimeter got multiplied by the scale factor as well to give us our new perimeter. And what happened to area? Area was a little different. It took the original area and we multiplied by the scale factor squared to get our new area. Today we're just going to be focusing on perimeter. This relationship will give us shortcuts to finding perimeter for similar figures. Before we do that, we're going to take a look at an actual example and see, does this relationship hold up for similar figures, ones that we haven't dilated by hand? So here are two shapes that are similar. We have KLMN and PQRS. We're going to find the perimeter of each and then compare them. So for KLMN, we have 21 plus 9, which is 30, plus 12, 42, plus 15. That's 57 millimeters. Let's look at the perimeter of PQRS. We have 28 and 12, which gives us 40, then 56, and 76. All right. So we have 57 over 76 as our ratio of the perimeters. Let's see what that simplifies to. Well, it simplifies to 3 over 4. You could either do that mentally or you could have used a calculator. Let's take a look. What was the scale factor for KLMN to PQRS? Well, we had 9 to 12, and 9 over 12 simplifies to 3 over 4. So the scale factor of the sides, 3 over 4, is the same as the scale factor for the perimeters. The ratios are the same. So the relationship we noticed in our dilation activity holds up for any similar figures. So let's formalize that idea. So we can say if two polygons are similar, then the ratios of their perimeters, like we had up here with the perimeter of KLMN to the perimeter of PQRS, that ratio is equal to the ratio of, and we're actually going to say corresponding side lengths. Just like we took the 9 over 12, those were side lengths. So it's equal to the ratio of corresponding side lengths. Oops, I'm running out of space here. So the ratio of corresponding side lengths. And the ratio of corresponding side lengths gives us the scale factor. So it's two different ways of describing this. So the ratio of perimeters is equal to the ratio of corresponding side lengths, or we could say the ratio of the perimeters is equal to the scale factor. Okay, so what does this practically mean? So if we are given KLMN is similar to PQRS, then we know if we add up all the sides of KLMN and divide it by the sides of PQRS, so PQ plus QR plus RS plus SP, that ratio will be equal to the ratio of any two sides. So it would be equal to KL over PQ. It would be equal to LM over QR. It would be equal to MN over RS. And it would be equal to NK over SP. And all of those are equal to the scale factor. So the ratios of the perimeter, the ratio of the perimeters, or the ratio of the side lengths, these are all going to simplify to be the same as the scale factor. Okay, so let's put that new knowledge to work. Let's take a look at this picture here. Use the similarity statement to find the scale factor of the polygon on the left to the polygon on the right. Then find the perimeter of each figure. This problem should look familiar. You did it in your 6.3 homework, And when you did it in your 6.3 homework, you had to find all of the missing side lengths so that you could find the perimeter. But the idea we just learned will help us take a shortcut. We can first find the scale factor, and then we can go straight to finding the perimeter without finding all of the missing sides. So let's find the scale factor. LM corresponds to PQ based on this similarity statement here. So LM over PQ is 9 over 12, and that's the same as my scale factor, which is 3 over 4. Now that we know the scale factor, we can set up a ratio. We can say the scale factor, or the side lengths, which were 9 over 4, those are equal to the perimeter of LMN over the perimeter of PQR. Do we know the perimeter of LMN? LMN, we have all the side lengths. We can add them up to get the perimeter. 21 plus 9 is 30, plus 15. The perimeter of that is 45. So I'm going to write a new ratio. I'm going to say 3 over 4 equals 45. That's the perimeter of LMN over the perimeter of PQR. Now we have a proportion, and we know how to solve proportions. We do 3 times the perimeter equals 4 times 45. So 3p equals 180. Divide by 3. The perimeter is 60. So we didn't have to find our missing side lengths of QR or PR to find the perimeter of this shape. All we needed to know was the scale factor and the perimeter of one shape so that we could find the perimeter of the other. Okay, let's go to another problem. I'm going to clean the screen here so we can start fresh. All right. Looking at number 11, given triangle CDX is similar to triangle GNZ, the perimeter of CDX is 48 feet, the length of segment CX is 14, and the length of segment GZ is 58.8 feet. Find the perimeter of triangle GNZ. Now, some students in class wanted to draw a picture of these triangles and mark what they knew. You can definitely do that. That is one strategy. The other strategy is to go straight to a proportion. And we know that the perimeter of CDX over the perimeter of GNZ is going to be equal to our scale factor, or the ratio of corresponding sides. Now, I was given CX and GZ. Let's see if those are corresponding. CX, those are the outside letters here, and GZ, outside letters. So those are corresponding sides. So I can set up a ratio with CX over GZ. So the ratio of the perimeters is equal to the ratio of corresponding sides. Now we're ready to fill in what we know. We know the perimeter of CDX, it was given to us as 48 feet. So 48 feet over the perimeter of GNZ, and that's what we're trying to find, so we're going to leave it as a variable, equals the length of CX, that's 14, over the length of GZ, that's 58.8. Now remember, it's important to make sure these line up. If this is the perimeter of CDX, this needs to be aside from CDX. Perimeter of GNZ, this needs to be aside from GZ. So we've set ours up correctly. Now we're ready to cross multiply. If I cross multiply, 48 times 58.8 equals, I get 14 times, I'm going to just abbreviate to perimeter, but we know that's still the perimeter of GNZ. Then I can actually multiply this out, and I get 2,822.4 equals 14p. Now this obviously would be a calculator problem. You do not need to do this math mentally. I'm going to divide both sides by 14, and I get 201.6 equals my perimeter. Now I don't want to forget units. My units are feet. So make sure you got that in your answer. So the perimeter of GNZ is 201.6 feet. Okay, at this point, you are done with the notes, unless you'd like to see one more example. I'm going to do number 12, but in class we only got to number 11. So let's clear the screen again. All right. Given triangle ABC is similar to triangle DEF, ABC is isosceles, and ABC has a perimeter of 18 inches and a leg length of 15, and the base of triangle DEF is 34.4. Find the perimeter of triangle DEF. Now here, I think a picture really will help us because we're given additional facts like ABC is isosceles. So let's draw this. We've got A, B, C. We know it's isosceles, and we have triangle DEF. If they're similar, DEF also has to be isosceles. We're told the perimeter of ABC is 18, and we are solving for the perimeter of DEF. It says the perimeter of ABC is 18 and has a leg length of 15 inches. Now remember when we studied isosceles triangles, the legs are the ones that are congruent, and the one that isn't is the base. So this is a base, this is a leg. Okay, so we're told the legs are 5 inches. So 5 and 5. And we're told the overall perimeter is 18. That means I actually know what my base is. If I have 5 and 5 and the total perimeter is 18, my base is 8 inches. Okay, we are also told that the base of DEF is 34.4 inches. So 34.4 inches. Now I'm ready to set up a proportion. So I can do the perimeter of ABC over the perimeter of DEF is equal to the scale factor or the ratio of corresponding sides. Well, I have AC and DF, which are corresponding sides, and I know their lengths. So I want to use that. I need a ratio where I know both lengths. So the perimeter of ABC is 18 inches. I'm looking for the perimeter of DEF. AC I know is 8, and DF is 34.4. Okay, so let's cross multiply. I get, and I'm going to move over here, 8 times the perimeter equals 18 times 34.4, which is 619.2. Divide both sides by 8, and I get my perimeter is equal to 77.4 inches. Don't forget units. All right, you are ready to do the homework.